Hey Valley Middle, today I'm going to try to teach you everything you need to know about Chapter 10 in about 5 or 6 minutes. Let's get started. Alright, first of all, you are going to need to know how to classify angles. Remember, a 90-degree angle is going to be exactly 90 degrees. It'll usually have that little square in the corner. Anything less than that is an acute angle. Don't forget, obtuse angles are those big, ugly angles that are more than 90. And then a straight line angle or a straight angle is 180 degrees or just a straight line. That is really important to remember. All right, we have to know that vertical angles, these are opposite angles. A and C are vertical. They're opposite and they're equal. If this is 110 degrees, this is 110 degrees. If this is 70 degrees, this is 70 degrees. Adjacent are any two angles that are next to one another, like C and D. These two angles are adjacent. Let's jump over here. D and A are adjacent. A and B are adjacent. C and B are adjacent. And C and D are adjacent. Let's try a couple. What is angle 2 here? Great, it's an obtuse angle. How about angle 1? Awesome, it's acute. How about this straight line here? Angles 1 plus 5 plus 4. It's a straight angle. All of these angles here add up to be 180 degrees. All right, let's keep rolling. You need to understand that whenever you have two lines that intersect, like these two lines here, first of all, the sum of the angles will be 360 degrees. Add them up. 110 plus 70, that's 180. 170 plus, or 110 plus 70, that's 180. Wait a minute. Are you telling me that, wait, 70 plus 110? Well, that's 180. 110 plus 70, 180. All of these angles will add up to be 360 degrees, but any two adjacent angles will add up to be 180 degrees because together they make, kind of like a circle, 360 degrees, but these two have to add up to be 180 because this line here is bisecting a straight line, cutting it into two different angles. All right, so the adjacent angles will add up to be 180 degrees. All right, let's try this. What's the measure of angles 1 and 2 together? Yes, you're right, 180 degrees. What is the measure of angle 2? Good, it's got to be 60 because this one is 60 and vertical angles are equal. How about angle 1? What's the measure of angle 1? Okay, well, it would be 180 degrees minus the 60 because these two angles will add up to be 180. All right, let's keep rolling. Next, you need to understand about complementary and supplementary angles. Two angles are complementary when they add up to be 90 degrees. Check these two guys out. 80 plus 20. What? They're not. Those don't add up to be 90. Something's wrong with my system here. How about 70 and 20? Does that add up to be 90? Good. These two are complementary angles. They add up to be 90 degrees. They don't need to touch one another. They just need to add up to be 90 degrees. These two angles are supplementary. I call it supplementary, remember? Because it's a big angle, like a big meal, supper at the end of the day. They add up to be 180 degrees. Notice they do not need to touch. These two lines here are both supplementary and form a straight line. So these are called linear angles. 120 plus 60, 180 degrees. Plus, they are joined, forming a straight line. So therefore, they're called linear. All right, tell me some true statements about these angles here. How about 2 and 3? They are supplementary because they add up to be 180 degrees. They are also adjacent. All right, let's try some of these on, where's that worksheet? Good, here we go. What angle is complementary to 68 degrees? Well, it's just 90 minus 68. Looks like that's going to be 22 degrees. How about this one? What angle is complementary to 21 degrees? Well, that's going to be 90 minus 21 degrees. Should be 69 degrees. Okay? Let's keep rolling. We also need to be able to classify triangles. You classify triangles like Super America. You need to talk about the sides and the angles. First of all, when we classify triangles by their sides, we're talking about how many of their sides are the same length. Scalene triangles, big, ugly, scalene, I think that's kind of an ugly looking word. Nothing is the same on any of them. All three sides are different. Isosceles kind of looks like this goofy looking dunce hat. Two sides are similar. Notice they mark the two sides that are similar with a little tick mark. Here, an equilateral triangle has all three sides that are the same. So for any triangle in the world, you can look at it and say it's either scalene, isosceles, or equilateral. You can also look at them and classify them by their angles. You can say that they're acute. This one has 3 acute angles. They're a right triangle. They'll only have one right angle, which is 90 degrees, or an obtuse one. This one here has one obtuse angle, so that's called an obtuse triangle. All right? This one happens to be an obtuse scalene triangle. Yeah, you can classify them by both their sides and their angles. Let's take a look. How about this triangle here? Classified by its sides and its angles. All right, you are correct. This guy here is an isosceles, and it is acute because all of its angles are acute. This one here is a right triangle, and it's isosceles. Look at these two sides are the same. This one here is an obtuse, and it's scalene. All the sides are different. And number 4 here, I don't think you can quite see it. Let me see if I can move it quick. Well, I'll just move me. Hey, there we go. This one here, I can't get rid of it. This one here is an equilateral, and of course it's acute because equilateral triangles, all angles are the same. All right, let's keep rolling. How am I doing? I'm over 6 minutes. All right, you also have to know how to find the missing angle on a triangle. Missing angles on triangles are real simple. You take 180 degrees and you start subtracting. It would be 180 degrees minus 20 minus 15, and that'll give you that measure of that obtuse angle. Remember, all triangles have 180 degrees. This one here, a little tricky. 180 degrees minus 30. That's going to give you 150 degrees. But because two sides are the same, these two angles will be the same. You can take the 150 degrees and divide it by those two angles. And you'll get it. All right, let's keep rolling. You need to be able to identify quads or quadrilaterals. There are lots of different kinds of quadrilaterals. Here's a trapezoid. Notice that they have the symbol on there for parallel, which is these two little arrows. A trapezoid has exactly one set of parallel lines. These are called the legs. These are called the bases. These are parallelograms. Parallelogram has exactly 2 sets of parallel sides. Look at all the markings on here. These markings are saying that this side and this side are the same, and this side and this side are the same length. These double arrows show that this line is parallel with this line. This one shows that this line is parallel with this one. There's a whole system of codes here. Hey, look at this angle is equal to this angle. 2 lines show that this angle is equal to that angle. Yes, in parallelograms, the opposite angles will be equal. A rectangle, we know all about it. We all know about squares. Rhombuses, they look like a square that is ready to party. It looks like it is dancing because it is leaning to the right, or maybe it's leaning to the left. All right, let's keep rolling here. Don't forget about kites. Here's a kite. A kite is going to have 2 sides that are congruent, the same length, but they're going to be next to each other. They are going to be adjacent. Look at these 2 sides are congruent, and these 2 sides are congruent. Hey, it makes sense. The other cool thing about kites is that when you bisect those angles like that, they meet at a 90-degree angle. All right, don't forget, a quadrilateral is just any 4-sided shape. It doesn't have to have any congruent sides or any parallel sides or anything like that. Oh, quick test. Here we go. What is this one? Parallelogram. This one. Rectangle. Here. Quadrilateral. This one. Trapezoid. This one. Ah, did you say kite? It's a rhombus. All 4 sides are the same. Again, it's just a square that doesn't have right angles. All right, let's keep rolling. What have we got here? Let's keep rolling. Quadrilateral angles. Every quadrilateral has a total of 360 degrees in it. You want to know how to find the missing angles? All you have to do is find out what this one here is. You take 360 and you subtract this angle, you subtract this angle, and you subtract this angle. Whatever the remainder is will be the measure of angle x. Okay? Not sure why there's 360 degrees in a triangle or in a quadrilateral. Take any one vertice and you can only make one triangle out of it. here, I'm sorry, you can make 2 triangles out of it. Start here, connect this one here, there's a triangle here, and there's a triangle here. Each triangle has 180 degrees. That's why we know that we can prove that a quadrilateral has 360 degrees, because 180 plus 180, the sum of 2 triangles, is 360 degrees. Let's try a couple. What's the missing angle right here? It's 110 degrees, because this one's 110 degrees. Well, wait a minute. If this one's 110 degrees, what's this measure? You're right, it's 70, because together these 2 angles in a parallelogram will add up to be 180 degrees. Guess what? This one here, the opposite angle, is also 70 degrees. So 110, 110, 70, and 70. How about this one? What's this angle? It's 55 degrees. How about this one? It's 125. It's 180 minus the 55. What I'm trying to say is, when you got a parallelogram of either a square, a rectangle, or rhombus, any parallelogram, all you have to do is know that the opposite angles will be equal. All right, let's keep rolling. What else have we got here? We have to know how to decompose a polygon. We need to know how to find the sum of all of the angles in the interior. Remember how we found out that a quadrilateral had 360 degrees? Well, you do the same thing with any convex polygon. Start at one vertice, see how many triangles that you can make. I was able to make 3 triangles here. That means in this pentagon, 1, 2, 3, 4. In this pentagon, there's the 5 sides. It has 540 degrees. Here's a pentagon 2. Look at, I can connect this one to make a triangle. I can connect this one to make a triangle. 1, 2, 3 triangles, 540 degrees. Okay? You can also use this handy-dandy formula. You can take the number of sides and you can subtract 2 and multiply it by 180. Let's try it. There was 5 sides here, right? We take 5 minus 2, which leaves me the 3. We multiply it by 180, and we have 540 degrees. All right, let's try a couple. How about here? What is the sum of the interior angles of this shape? Here, well, let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. Okay, so 8 minus 2 is 6. 6 times 180 will be your answer. 6 100s is 600. 6 80s is 480. The sum of the interior angles of this polygon would be 1080 degrees. All right, thanks for doing Chapter 10 with me in 12 minutes. Sorry I couldn't do it in 6. Have a great day.